What is going on YouTube? Just helping you out here. And for today's video, I will be doing Chapter 15, Problem 1 in the Fundamentals of Physics textbook, 8th edition by Gerald Walker, Halliday, and Resnick. Chapter 15 is all about oscillations, and in Problem 1 we're asked to find the maximum acceleration given an amplitude and frequency. And so we know that maximum acceleration is equal to omega squared times xm times the cosine of omega t plus phi, where omega squared is our angular frequency, xm is our amplitude, t is time, and phi is our phase shift. And in order for a to be a maximum, this quantity right here must be 1, because the maximum value that cosine can take on is 1. So this right here is equal to 1. And so our A max is equal to omega squared times xm. And so first I would like to find omega, and we know that period is equal to 2 pi times 1 over omega. And we also know that period is equal to 1 over the frequency, and we're given the frequency in the problem, and so we can rearrange this equation by multiplying omega over here and frequency over here, and so we find that omega is equal to 2 pi times the frequency, and we have all those values in the problem, so this is equal to 2 times pi times 6.6 hertz, which is equal to 41.47 radians per second. And now we need to find our amplitude, and we're actually given that in the problem, so xm is equal to 2.2 centimeters, but we can convert that to our standard unit and say 100 centimeters in 1 meter, so that'll be equal to 0.022 meters. And now we have everything we need to solve this problem, so A max is equal to omega squared, which is 41.47 radians per second, that's squared, times our xm, which is equal to 0.022 meters. And if you plug all of that into your calculator, you should find that your A max is equal to 37.8 meters per second squared. So that's about it for this problem. If you found this video helpful, please drop a like, leave a comment if you have a question or an idea for a future video, and lastly, please don't forget to subscribe and tell your friends about my channel so I can grow and help more of you guys out. I'm just helping you out. See you in the next video.